Hi, in this video I'll be introducing you to scientific notation. So what is scientific notation? Well, sometimes they're really big numbers or really small numbers, and it gets really annoying to write down all the digits. And because they're so big, we can just kind of chop it up a little bit and write it in a different way. All right, so what do I mean? I sound crazy, I know, right? I can't just chop the number up, but alas, that's what we're going to do. All right, so the rule for scientific notation is that we want to write the number as a number between 1 and 10. So here I'm looking at this number, and there is no way that you can actually put this as a number between 1 and 10, but again, alas, that's what we're going to do. So, but in order to do that, we would have to imagine a decimal point at the end of the number, and we would have to imagine moving it over 1, 2, 3, 4, 5, 6, 7, 8 times to get between the 7 and the 2. And so the number that we'd have here is 7.25. But you may be wondering, well, if somebody owed me this much money, there is absolutely no way that I would take this much money. And that's good intuition, right? There's no way that you would take $7.25 if they actually owe you that much money. So what then? What do we do to fix that problem? Well, in order to fix that problem, then we have to now multiply the number that we created. So this number here, we have to multiply it by a power of 10. And since we moved the decimal point over 8 times, we're going to multiply it by 10 to the power of 8. So that's how you change a number from standard notation to scientific notation. So again, just to recap, we looked at this really large number. We wanted a number between 1 and 10. So we figured out how many times it would take us to move that decimal point over to get a number between 1 and 10, and we got 7.25 when we moved the decimal point 8 places. All right, feels a little uncomfortable at first, but totally allowed. Let's try another one. Okay, so here we're looking at a really small number, and we would like a really small number, again, remember, to be a number between 1 and 10. That's the rule. We want a number between 1 and 10. So we would have to take our decimal point and move it 1, 2, 3, 4 times, but this time in the other direction in order to get a number between 1 and 10. So our number is 4.12. But again, we cannot say that these two numbers are the same. There's no way you could get away with saying this number and this number are the same. So you do have to, again, compensate for that movement by multiplying by a power of 10. And since we moved the decimal point 4 places, then this number is 4.12 times 10 to the negative 4. You may notice that I now have a negative exponent. The reason for my negative exponent is because this is a very small number. When you have small numbers, you compensate by getting a negative exponent for your power of 10. When you have a really large number that you're writing, this instead would be a positive exponent. All right, let's try one more, but this time let's try going in the other direction, changing from scientific notation to standard form. Okay, so here we have 9.83 times 10 to the negative 6. You may recall that the fact that this is a negative exponent is telling you that this is a really small number. It's also telling you that that decimal place has to be moved over to the left 6 places to get the actual number in standard notation. All right, so let's go ahead and do that. Let's write it down here. 9.83, and we're going to take that decimal point and we're going to move it 6 places to the left. 1, 2, 3, 4, 5, 6. These things are just floating in air. The decimal point will be there, so it will be 0.000000983. And let's just write that in one color to make ourselves feel a little bit comfortable here. 0.0000983. 983. And if you wanted to double check it, since you know how to go the other direction, by all means, just double check and see if you actually would go 1, 2, 3, 4, 5, 6 places to get 9.83. Looks good. We're now in standard notation, and this is the correct answer.